Hi there and welcome to another video from Hegarty Maths. It's Mr Hegarty here and it's a Decision Maths A-level video and we're talking about critical path analysis, the fourth video in that series. In this video I'd like us to be able to carry out what's called a forward and backward pass on an activity network to calculate the early and late event times, and I'll explain what those mean. So let's just review where we are at the moment. So far we've got to a point where we can translate a paragraph to a precedence table, and now we can draw an activity network including dummies. So here's an example of an activity network with a dummy in it. So for example, this tells us that E depends on C happening and F depends on D happening and B happening, etc. But now we want to talk about the time the project takes. So what we're going to include along each activity, we're going to include the time that activity takes. So I'm going to transfer a graph like this, an activity network, to something like this, where I put the numbers beside each activity to tell you how long they'll take. There's a missing line missing there. Okay, so for example, this is telling us that C, it's telling us C depends on A, but it's also telling us that C takes 4, say, hours long or minutes or whatever it is. So it also tells us the time. Note a dummy adds no time to the network at all. So that's the next point I want us to get to. Now these will be given to you in the exam, okay? But the very next thing you need to do, and again these diagrams will be given to you, you won't have to draw them from first principles yourself. I'm just going to convert that to this picture here. Nothing's different other than at each activity I've drawn a box rather than a circle with two boxes, one on top of each other. Okay, and I'm going to fill this out and explain what filling out means by finding the early and late event times by doing a forward and backward pass. So, firstly, the top box in any of this section means the early event time, and I'm going to write down what that means. So make sure you get a copy of this book. The early event time, well, this is the earliest time of arrival at that event once all the preceding activities are completed. So once all preceding activities complete. So for example, here, let's say, whatever number I put in there will be the time that you can get to having C done, where every activity required to get C done is complete. Okay? Now what's the late event time? The late event time is defined as the following. It's the latest time that the event can be left without extending the time for the project, without extending the overall time for the project. Okay, so what I mean by something like here, it's the time at which you're, the latest time you can leave having done event C, so start doing event E without making the overall project slow down. Okay, so early event time is about what's the earliest time you can get to this point, having everything done beforehand, and the latest event time is the latest time in which you can leave this event in order to do a new event without slowing down all the project until the overall hours for the project. Okay, so that's what early and late event time means. And we carry out the early event time. We find this out by what's called a forward scan or forward pass. And we work out the late time by what's called a backward pass. And I'll go through two examples of this for you so you can clearly see what each of these mean. Now, let's fill in the source node. So this is the source node. Clearly, you just want to start this at time 0. Okay, so the earliest time would be 0, and you always put 0, 0 in here. Okay, obviously you want this to have been left at 0. So if you want to start this at 0, so you always put 0 and 0 in there. So let's consider this box here. Let's do a forward pass, and in the forward pass, what I'm going to complete, I can always complete the first two, but then I'm going to complete every early event time in this pass. Okay? So, add this box here. What is the earliest time I can arrive here with everything done that needs to be done to get here? Well, the only thing that needs doing to get here is A, that takes 2. So if I could get here at the earliest time of 2. Obviously I could get here at 5 or whatever, and the A would be done, but the earliest I can get here is 2. Let's go here. What's the earliest I can get here with everything done that needs to be done beforehand? Well, it's 7, isn't it? So I'm going to write 7 here because B is the only thing that needs doing. Okay, what about C? What's the earliest time I can get here with everything done that needs doing? Well, in order to get here, C and A have to happen. And if they happen perfectly one after each other, that would take 2 hours and that would take 4 hours. So it would be 6, which is 2 add 4. How you got that? Okay, let's think about D. Now, D's where maybe it might start getting slightly complicated. There should have been a line in there as well, by the way. Okay, D may be where it's going to get slightly complicated. Let's think about this. How do I get to this point in the earliest possible time? Well, what needs to happen? A and D need to happen, and A and D, if A and D happened, that would take 2 add 3, which is 5. But also to get here, B must happen. B and this dummy, which has nothing. So B must have happened to get here, and B takes 7. Now, all these 3 things must have happened to get here. Okay, so the earliest time I can get here with everything done must be the biggest of these numbers, which is 7. Okay, so when you're doing a forward pass, you're looking for the biggest of all possible routes to get there, and it's going to be 7. Okay, now we've done here, let's go to the last one here. Now let's think, everything must be done to get to this point. So A, C and E must be done. A, C and E, A, C and E would have added 2, 4 and 2, which would be 2 plus 4 plus 2, which is 8. That's one way of getting here. Or A, D and F must be done, which is 2, 3 and 4. So A, D and F, which is 2 plus 3 plus 4, which is equal to 9. But also B, dummy and F must have done, which is 7 and 7. So B and F, which is 7 plus 7, which is 14. Or it could have been B and G would have been 7 plus 1, which is 8. Now, everything must have happened. So in order to have everything happened, everything, B and F took the longest, so the earliest I can get here is the sum total of, B and F, it was 7 plus 4, which is 11. So 7 plus 4, 11 goes there. Okay, and now what I'm going to do is I'm going to fill in all the late event times by doing what's called a backward pass. I'm going to explain what that means here. Now you always put this number in the bottom here. So you want to put 11 there, and we look back at each of the possibilities and do a backward pass this way. So let's start by looking at C. Okay, what's the latest time you could have left C not to delay the project? Well, in this event takes 2 hours here, so I would have to left here at 9, which is 11 take away 2, so I would do 11 take away 2, which is 9. I'd have had to leave here at 9 in order not to delay the project. What about here? What's the time I should have left here? Well, I have to, when I leave here, I have to complete F, which is 4 long, and have to get there for 11. So I would do 11 take away 4, which is 7. Okay, so I have to leave here at 7. If I left here at 8, I'd delay this project and it would finish at 12, for example. Okay, now let's go to, why don't we go to this one here? Let's think about when we had to leave here. Now, when I leave here, I've got to do a project that's 4 long, okay? So, and I've got to be there by at least 9 not to delay the project. So if I do 9 take away 4, I have to at least leave here at 5. But what about this element here? Here I do 7 take away 3, which is 4. So I have to leave here at least 4 in order not to delay this element here. Now I'm going to pick the smallest of those numbers. On the forward pass I pick the biggest, on the backwards pass I pick the smallest. So I'm going to say that's 4. Because if I left here any later than 4, say if I left here at 5, yeah, that's not delayed, but I end up delaying this because 5 add 3 would be 8, and that's delayed. So I'm going to pick the smallest number, which is 4 here. Let's think about this one here. When do we have to leave this event here? Well, I do nothing along here to get to 7, okay? And so this makes me think it's 7 subtract nothing, which is 7 for this one. But this one, I'd have to leave here at least 10 to get there by 11 because of the one activity. So this would be 11 take away 1, which is 10. Now I'm going to pick the smallest of those numbers, which is 7. There. And 0 isn't backwards there. So I have completed the forward and backward pass to calculate what's called the early and late event times. Just to think what they mean. So let's think what they mean. Like any one in particular, this one here means I have to leave, the earliest time I could arrive at this event, having completed A, is at 2. But I have to have left here by 4, otherwise I will delay the project. Now if I leave here at 4, I'll be finished this one by 8, which is fine, it doesn't delay that. Whereas if I leave this any later than 4, because this is 3 long, this will make this be bigger than 7. Okay, so this is the latest time I can leave this event without delaying the project. Okay, and just to review, how do I calculate the early event times, where they're the top numbers in yellow, and I calculate them by looking at the biggest possible number that they can be, looking at all the activities that need to be completed to get to that. How do I calculate the late event time, where they're the bottom numbers in green? And what I do is, going backwards, I look at the smallest numbers that these numbers could be in order to get to the number after it without delaying the project. Okay, so we're going to do another example just to make all that clear and show you exactly how to write it down in an exam sort of standard question. So let's give this a go. If you feel really confident, pause the video and try this yourself. And if you don't feel really confident, well then watch me in 5 seconds go through it. Okay, so we want to calculate the early and late event times. Now the early event times are the top numbers, which I'm highlighting in yellow. So these are the early event times. Remember what they mean. They're the earliest time I can get here with all the activities beforehand that are needed to get there complete. And I calculate those using a forward pass. And I'm looking for the, I'm looking for the biggest number possible into that. And the late event times, they're the bottom numbers here. And they're called the late event times. What do they mean again? Well, they're the latest time I can leave this event so as the project is not delayed in going forward. I calculate these doing a backward pass, and I'm looking for the smallest number when I'm doing that backward pass. So let's see if we can have a go at doing these. Right, let's deal with A first. What's the time that should go here? The only event that has to happen is A, which is 8 long. So the earliest time I can get here is clearly in 8. Let's look at B. In order to get to this event, the only activity that has to happen is B, which is 6. So 6 has to go in there. Okay, now let's look at C. The events that the activities that need to happen to get to this event are A and C only. Okay, so the earliest time I can get there is the sum of 8 and 9, which is going to be equal to 17. So I'm going to put 17 in there. Let's think about D now. What needs to happen to get to D? Well, A and D need to happen to get to this event, sorry, the event after D. So A and D have to happen, which is 8 and 7, which is 15. Okay, now let's look at E. So for E to have happened, so for this event to have happened, B and E must have happened, which is 6 add 5, which is 11. So 11 is the earliest time I can get there. Now it's where it might start getting a bit tricky here. To get to this event, what needs to have happened? Well, F needs to have happened and anything before it, and also this dummy needs to have happened, okay? So it's going to be the biggest number out of the F root, which is going to be 8 add 9 add 4, so 8 add 9 add 4, which is 21. It could either be 21 or it could be this root, which is 8 add 7 add nothing, which is 8 add 7 add nothing, which is still 15. Now you're looking for the biggest number, so you're going to put 21 in there. Okay, so 21 goes in there because that's the earliest time I can get here with everything that needs doing. Yes, I could get there in 15, but that would be excluding the fact that C and F have to have happened. Okay, so 21 is the number that goes in there. What goes in here? Well, it's the biggest possible number, so it's 21 add 5, which is 26, or it's 15 add 5, which is 20. So it's clearly the biggest, which is 26. And lastly, how do you get here? Well, it's either, out of interest, one thing I didn't consider here, which I should be super careful of, the 11 plus the 8 was 19, okay? That could have been bigger than the 26, in which case I had to include that. So when looking at here, I had to do 21 add 5 is 26, I had to do 15 add 5 is 20, and 11 add 8 is 19. 26 was the biggest. How do I get here in the biggest? 26 add 5 is equal to 31, 11 add 5 is equal to 16, so it's clearly going to be 31. Now going backwards, we're going to write 31 in here, and we're going to think of, we're going to look to this one first. What's the latest time I have to left here so as not to delay the project and get there in 31? Well, it's 31 take away 5, which is 26. What about this one here? What's the latest time I could have left here? Well, either it's going to be 31 take away 5, which is equal to 26, or it's going to be 26 take away the 8, which is going to be equal to 18. And I'm looking for the smallest of those numbers, so it's 18. Now the reason it's 18 and not 26, as long as I've left here by 18, 18 add 5 is less than 31, so I haven't delayed that, and 18 add 8 is 26, so I haven't delayed that. So I'm picking the smallest of those numbers, so it's 18. Let's look at this one here. What's the latest time I have to left there? Well, it's either, it's 26 take away 5, which is 21, so it's going to have to be 21 in there. It's only one option. What about here? Well, I have to have left here in 21 take away 4, which is 17. Now what about here? When do I have to have left here? Well, it's either 26 take away 5 for this root, which is 21, or it's a 21 take away nothing, which is 21 again. So it's going to be 21. What's going to go in here? Well, this one's either going to be 17 take away 9, which is equal to 8, or it's going to be 21 take away 7, which is equal to 14. I want the smaller, so I'm going to choose 8. And what about this one here? Well, it's 18 take away 5, which is 13. And I get myself back like that. So that there is the forward and backwards pass to calculate the early and late event times. Okay, and just to have a think here, at any time, just to see if you understand it fully. What this means at this point here, this means in order to be here, I could get here at 15 at the earliest, and I have to have left here by 21 at the latest so as not to delay the project, okay? Now, there's something quite important. When you have, I'm just going to highlight one of these because the next video is going to be about this activity here. Let me just highlight this activity for you, C. Now let's just think about C, which is the whole of the next video is about, but I just want to introduce it to you here, activity C. Okay, so for activity C to occur, this is the picture we've got. 8, 8, activity C happens, and we get here at 17, 17, and this is 9 long. Okay, so let's think about activity C. The earliest time I can get to this event is 8, okay, and the latest time I can leave here is 8. So I have to get here at 8 and leave here at 8, not to delay the project, okay? And because the activity is 9 long, the earliest I can get here is 17, but also the latest I can leave here is 17. So activity C is called critical. And it's critical in the sense that if I increase the duration of this activity at all, it's going to delay the project. Okay, so it's called a critical activity. Now I just want to show you that versus something that's not critical. So in not critical, why don't I pick something like activity E? So let's draw out what happens in activity E. The event before it is 6:13. Then activity E happens, which is 5 long, and you get to 11:18. Okay, now let's think about this. For activity E to happen, I must get to this event, the earliest I can get to the event is 6. But I can hang around till 13 before I leave there and do activity E. Okay, so I've got some, because it's 5 long, I could leave there anywhere between 6 and 13. Okay, because if I add 5 onto 6 I get 11, and if I add 5 onto 13 I get 18. So I've got some variability. I don't have to leave here at 6 at all. I can leave here, I can hold back until 13 and I won't delay the project. Whereas in this case with C, I had to get here at 8 and leave here at 8, and so the activity was critical. So E is called non-critical. And I'll quickly introduce it to you here. There's something that you call float, and float is your sort of spare time here. Okay, so the float is the latest finishing time. In this case it would be 18, subtract the duration of the activity, which is 5, subtract the early start time, which would be 6, and I have a float there of 7. And the way I make that float to myself understood, I could leave here anywhere between 6. I can get here at 6, so I could leave here at 6. It's 5 long, okay, so that would take me to 11, but as long as I left here before 18, I'm fine. So I've got a slack of 18, take away 5, take away 6. Okay, so this number, take away this number, take away this number. Okay, will give me the flow. That's the spare time I have without delaying the project. And that's it in this video. I'm going to talk much more about critical activities and non-critical activities and floats in the next video. Thanks for watching.